Welcome everyone to MNG Studio, and in this video we'll discuss about why we use containers. If you were to build an online retail application with user sign-in, inventory management, billing and shipping, you could break up your application into these modules, each requiring a number of software instances running on a number of machines to scale. They may have their own hardware and software requirements to run and scale properly, such as operating system, RAM, CPU, disk, networking, and even software dependencies. Instead of writing these requirements in code, you can declare them outside your code in configuration files called containers for easy management. Let's get started looking back in the old days how applications were built on the individual bare metal servers. You usually had to install the hardware, you had to install an OS or a kernel. On top of that, you had all these dependencies that you installed also, and then after that you have installed your application code. Even after doing all that, it usually became really hard to keep the application dependencies and everything in sync. So VMware came up with a way to hypervise your hardware, in other words, decouple your hardware from your kernel, from your dependencies, and from your application. So they developed a hardware hypervisor layer that sort of decoupled the application itself. Like I said, everything above the hardware liberated it. That was one abstraction level, but we had a problem back then. Problem is that you cannot install the same application or multiple versions of the same application into one VM. If you do that, you have dependency errors, you have conflicts, and so forth. So the answer back in the old days again is to create more virtual machines. So yes, sometimes you would have this scenario here where you have multiple virtual machines, many virtual machines probably running even the same instance or the same version of the same application, but the same reason is you could not run them all on one virtual machine due to dependencies. So it was costly, ineffective, and hardware ineffective also. Finally, what we see right now is a different level of abstraction. We have decoupled with VM and the hypervisor, the hardware layer on the bottom, then with the kernel and container runtime and the container itself. We have decoupled that completely from any dependency in any application. The good thing about this, it's portable, it's very efficient, it's inside that has no dependencies again on the kernel or the hardware itself. Why developers like this? Well, a couple of reasons. First of all, you could develop a cross-test in a production at the same time. You could also run this on bare metal, virtual machines, or on the cloud. It could be packaged spread across speed of development, agile creation of development, and continuous integration and delivery. Also, you could have a single file copy or single instance storage for some. This provides a path to microservices, introspect, isolated, and elastic, all at the same time. I hope you enjoyed this video. Don't forget to hit the bell for more interesting videos, and thanks for watching.